Hey everybody, this is Larry. This is day 3 of the September Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this poem. It is Tuesday, as I said yesterday. Very tough day, very tired, but as they say, you know, YOLO. But today we have, I just went 7 miles, 8 miles-ish. A lot of it very fast and with a recovery, but I am just so done, so ready to sleep. And yet we are here trying to grind out another problem. We'll see how that goes. Yeah, let's just do it. I don't have much of an intro today. Some days, actually it was this way on the track as well. I also had nothing left on the track. I was just as tired as I am now, maybe a little bit less so, but not by that much. But yeah, some days, you can grind it out. Some days it is all hard, and hard is all you need, and what you get is what you get. Though that probably works better on the track than stuff like this, because my brain power is not there. Possibly. All right, let's take a look. We'll go as, not gonna lie, we'll go as fast as I can. As predicted yesterday, we did this back in a year and a half ago, so definitely check that video out if you have issues with this one. I don't remember how to solve it though, just to be clear, so we will still have a chance to take a look to well, just to give it a go. But yeah, I didn't really think about it since yesterday either, so I don't know whether you believe me or not, who knows. But yeah, all right. All right, well, okay, we have the same thing as before, right? Okay, the right is increasing x, left is negative. Okay, that part is fine. If n people, Alice and Bob, one person at every point. Alice wants to be alone with Bob. Okay, was this in the text yesterday? I don't. I don't remember this, but maybe I'll just go really fast. Anyway, yeah. Rectangular fence about upper left corner and Bob as the lower right. I think someone left the comment saying that I confused A and B, and you're probably right. But I would also say that like it doesn't really matter. You just have to kind of draw it out. I might have probably confused it. At the end of the day, you have to like it doesn't matter. I think, but. Oh, I'm tired. No god. Sorry, friend. Okay, so Alice is upper left, Bob is lower right. Okay, return the number of pairs where you can get Alice and Bob does not become sad on building the fence. So no. Oh, so in this one, no one is on the fence as well. Right? Yesterday I forgot how it goes, but. Maybe it's the same. It doesn't really matter because that one was just like an n cubed one, right? Okay, so you have this. Don't know why 1 1. Okay, so because it is not. I'm confused why this is. Alice is upper left, Bob is lower right. So is this valid or not valid? That's the part that I'm trying to figure out. I cannot understand this. It's not on the lower right corner of the fence, but it could have 0 area, right? So is that a valid one or no? I don't know. This is very weird. Okay, this one's 0. Okay, example 3 has an example maybe. I don't know why their font is so small. Was it always like there are 2 ways to play Alice Bob? Okay, 1 1 3 1. Alice at 1 3 1 1, right? So yeah, no. So this is valid, right? So I don't know. I don't know why this thing is. Oh, is it just saying that when you build a fence that is like 2 by 2, Bob is now in the lower right. That's a very weird. I mean, it's a weird. They should just put like one more point or something. I don't know. Why would you build a fence like that? In any case, okay. Yeah, okay. And it's 1,000 at this time. Unlike yesterday, which was like 50 or something, I had 50 or 100. So n cube is fast enough, and the points are big enough that it spans the entire. Might as well be infinity is my point. Okay, and this thing. All right. I think the first idea that I might have is to sort, right? I don't know. I mean, in general, for a lot of problems where the result in the order or the order in the result doesn't really matter, then we want to maybe sort just to give it a little bit of a structure, right? And now, what does the sorting tell us? The sorting means that it will go from left to right, and then given the same x, go from lower to top, right? So what does that mean? That means that later on, so that means that, okay, first of all, I mean, I think this is like very hard to do without visualization. I mean, or like, it's very easy to miss cases, right? So let me bring up the drawing board. I also, just to be clear, I do not know how to solve this one quite yet, so we'll explore it together. I mean, I don't know. I mean, I have some ideas about structure, but honestly, not quite sure, because it may end up being greedy, but greedy problems is just tough for me, as you know. Okay, so then now you have like, so we're saying that we're sort, which sort this way and then tie break by this way, right? So then now, okay, so if they're points on the same x, then what happens? Well, you can only do these things, so then you are Gucci, right? So you just look at adjacent elements, right? Right. Okay. Then now what happens? You have a different point. Well, if this is this point, then now you have kind of this, right? You have this point, then now you only have this, right? Maybe is that a fair way of doing it? If you have another point though, then yeah. So in a way, this just match 1-to-1, but that seems a little bit, because now if you added this point, then this is no bueno, right? So, but if you kind of look at it this way, then now maybe you can just say that you just take one that is on the previous, right? Maybe, yeah, to kind of have this properly. One more thing that I would say though is that what happens if you have someone like this? Well, no, this one would not be no bueno, but what if something like this, right? Then now you have both this and this. It counts. Keep in mind that n is only 1,000, so we can do n squared type things. We just can not do that much more than that. Maybe even n squared log n, if maybe, but it will have to be a fast square n squared log n. But yeah, but I think this is the trickier idea, right? So you have like this thing. So then now you have this triangle or not rectangle, and this is this rectangle. And then also as a result, then you have like everything that's like in between, kind of, right? As long as it kind of fits this thing. This does not honestly give me any ideas quite yet. I mean, maybe some ideas around like, finding like but well, okay, well, maybe that is an idea interesting, right? So okay, so basically for this point, for example, and maybe we'll redraw it out a little bit because now I'm concentrating in a little area, but okay, so that means that, let's say we have this point here, okay, let's say we have this point here, that means that there is some like step function, maybe not like that, but step function-y thing about the points, right? So it looks like something like this, right? Okay, but note that in every x, we only get the next one, right? So that means that for, I mean, I only have, from this, there is an n square log n, right? But I don't know if it's fast enough. I mean, it is, square log n is a very peculiar thing because in this case, n is 1000. So log n is only like 10, right? And binary search or bisect on an array is very fast, so maybe that's fast enough. But the idea here is that, okay, what are we trying to do here? Well, we have this point which we drew a line, and then we're just trying to get the next number, and that's a very easy binary search idea, right? I don't know if I, like, is there an n square one? Can I do a little bit better? Maybe? I mean, if you do a binary, and we could maybe upsolve it later, but maybe, well, the way that now I'm drawing it, I'm saying, okay, you could binary search, right? But also, honestly, it is like a sliding window, though, right? Because basically, well, let's say you have a previous point that's here, and that gives you, you drew here. Then now, when you draw the next point, and also keeping in mind that you have to do some stuff about, I mean, I kind of simplified this a little bit, but for example, if there's another point here, then now you have to chop it off or whatever, and then maybe do, part of the sliding window to go to the next one or something, right? So that, because otherwise, then now you have this thing. But I think with this sliding window idea, we should be good, right? So we go from here to here, and then now we just, as part of the check, we just go to the next number, right? And well, on this line, there are at most n points. It's not quite like this, but in the previous thing, there's n points. I mean, you could maybe say n over 2 and n over 2 to get like n square. But even then, yeah, like it should be fast enough. So I think that's good enough for me to try. Unless I'm missing something, which honestly has happened a lot. But yeah, so okay, so we can do that, right? So then now we're sorted, and then we go from, which is what we want. So then maybe we have like maybe P for points. We want to just have a list. So P of X will contains all the Y points, right? On the X line. X equals, well, whatever, X line. I don't know if that's quite, that's not the right terminology, but that's fine. Then now for XY in points, right? Maybe we have like a previous X is equal to, in this case, it doesn't matter, so negative infinity. The reason why maybe I have a previous X is just so that when this is a new X, we have to start over with resetting some stuff. For example, because with a new X, if we're doing a sliding window thing, we just have to reset where we start. And I keep saying sliding window, it's not quite right. I meant sweep line, right? We have to reset the sweep line to the next line, and maybe that's fine, right? So then now if X is not equal to pref X, then X is, or the other way around, pref X is equal to X, but then now reset sweep lines. So maybe you could say, sweep is equal to just like a lookup thing, right? Maybe we'll set a default thing, but we set it to the same thing, right? And then now, or maybe just, yeah, I guess, I know that this is just roughly speaking the same as a counter, but but like semantically, it's a little bit different, right? I guess technically you just write int for default 0 for the first index. And yeah, it just keeps track of the indexes that we care about. And the idea here is that sweep of X will contain the current thing to sweep about, right? Okay. So then now, yeah. Maybe I want to do enumerate here, and the reason is maybe we'll discover in a little bit. But we just want to kind of, as part of the visualization, we want to not get the next number, right? So that's basically what we're doing here. right? Yeah, and then now for each yeah, so we are currently at y at x. So then this is just a regular sweep, right? For let's just say px for previous x in p dot keys, right? Then now we want to see, we want to sweep until the next number or next y, right? Yeah. So then while sweep of p sub x of, so this gives us the index of p, so it'll be p of this. Oops. While this is less than the length of no, actually this is the index, sorry. So yeah, p of px, while this is the case, then we can use it, right? So if sweep of px, well, I guess we could put in the while anyway, right? So while this is true, and sweep of px is, well, this is the index, so p of this is less than, I'm trying to think whether equal to matters. I mean, I have some inaccuracy, that an explanation that I have, but I just want to think about. But it's a little bit tricky, but we'll have to figure it out a little bit, right? While p is less than the current y, then we just increment, right? But this isn't quite right in that I kind of drew it in this way, but which allow us to kind of maybe generalize a little bit imprecisely. And what I mean by that is that the next, so we're looking at, let's just say we're looking at the green line, even though now I used another color. And I kind of did this thing with the step function, as we said, right? But the next black point could be here, right? If it's here, we actually cannot. Actually, can we use it? I guess we can, right? We can use this, but then we cannot use this one. Right? So what is the behavior that we're seeing? I mean, I this part I think a little bit fast on it, but the idea here is that, okay, well, we have this point that we're trying to figure out, and then the next one, the next biggest, and then we're trying to get a step function thing, and the TLDR, honestly, and for example, maybe the next one's actually, well, no, in this case, but it's just that it'll go smaller is when where you worry about, and then you have to reset. But yeah, and the TLDR, well, I mean, I think I know this, but let me double check a few cases, because for example, you have this, if it goes down, then now you reset it so that it does this, right? And then now let's say you have this, this, and then now this, then what happens? Do we go here? No, right? Because then now, oops. Because then now you pop, and then now you do here, right? Because let's say this is your point, this is your point, then now this area is where you draw the box, and if you try to draw it with either here or here, it would have overlapped, or you have the other point inside, and as a result, yep, okay. Just want to confirm. It's apology if the scribble is not explanatory, but it is for my purposes. And for me, it is more important. For me, honestly, and people might not agree with it here, because I get comment about it from time to time, but for me, it's more important that I show you how I think about the problem and attack the problem than to explain the problem, to be frank, right? And why did I say it like that? The reason why I say it like that is because, listen, you could you could click on solutions, you could click on editorials, you could click on another video, to be honest, right? Of people like telling you exactly how you want to think. But for me, that's I hope what makes more sense for or what makes this channel different is not doing the same thing that everyone else is doing, but to show you how I think about it and how I attack it and what kind of things that I need to do to prove to myself a little bit more anyway. Sometimes I still YOLO, of course. Right? Yeah. And I hopefully, that is what you agree with. Otherwise, I mean, it's fine. Watch a video that's you find is interesting. Doesn't have to be this one. Doesn't have to be my channel. It is what it is. But also just hit the like button anyway. Why not? Now, but yeah. But the idea that we have here is that now we're trying to get this in a way, right? And how are we going to get that? The short answer is with a monotonic stack, right? That's basically what I mean. When I know that I try to figure out some examples to kind of confirm, but when I was drawing the thing that I erased already, when I was drawing that was my inclination, right? And the reason why you have monostack is that you can just think of and this is why it's very, at least I consider visualization important, because the way that I say step function and step ladder or whatever, I visualize it mono-stacked in the same way, right? The reason is that then now you can say this is the stack, and then now you pop this off to put it here. You put this on the stack, you put this on the stack, and then now you have this thing, so you have to remove all the numbers that are bigger, which is going to be this one and this one. So then that's great. And of course there is this monotonically increasing property for reason, but well, for this particular problem it should not be monotonic, right? It should just be strictly increasing, because if you have a number here, you actually also pop this off, right? And then the key idea here is that now just when you have this mono stack that you maintain from going from left to right, you just the number of things in your final well, I want to say mono stack, but like I said, it's a strictly well, I guess it is still a mono stack because the stack itself is monotonic. No, I guess it's strictly increasing. I mean, strictly increasing stack, I guess, is a subset of the monotonic stack. So I don't know, whatever you want to say. But in any case, right, the number of count is the number of pairs that you can match with this point, and that's basically what we want to do. I was going to think about like some ways of backtracking, but now that I have that visualization, it gives me confidence to kind of figure that out. And then now that we sweep the next one, right? So then first we keep track of the stack, right? Yeah. And we even have a benefit that we actually, because of this mono stack property, we have a benefit that we can do later, right? So we sweep until the next y, right? So then now the invariant is that either we have no more points in this x, or this xy is the next y, right? Basically. And then now we can just apply this y to the stack. So while length of stack is greater than 0 and stack, the top of the stack is either less than or equal to y, then we pop. This is what we talked about. The other way, sorry. If it's greater than or equal to, we pop, right? So then now stack is basically going to be, or the current y is going to be the biggest y, right? So then that's basically the idea. Okay, so this is mostly good. The thing that we were saying with, and again, this is a very visual problem. For me, it's a very visual problem, right? Maybe, and that's why I want to bring it back up. One more thing that we have to consider is that the next point, right? So we have this point. The next point could be here. If it's here, then we have to get rid of stuff, at least for this point, because they all belong to this other point, right? So that's basically the idea. Yeah, and basically maybe the way that I can write it is that, and this is why I have the I here, right? I was setting it up. While right, so length of point, so while it exists, and points of I plus 1, the x-axis. If the x is equal to this x, then now that means if it's the same x, that means that the y is going to be the next on the same x, right? I said that weird, but hopefully, I mean, okay, right? Then now, yeah, if this is the case, then let's say next y is equal to points of I plus 1, 1, right? I'm just setting it up. And then now for the stack, while length of stack is greater than 0, and the top of the stack is, I guess, equal to, right? I mean, when I'm thinking, I know that's greater, but I just want to think whether it's greater than or equal to, right? Then now we stack that pop, and then after we clean that up, then the length of the stack is the number of points that corresponds to this point. So then maybe I just have a total or count. Maybe count's a little bit cleaner, more precise. And that's it. Hopefully I didn't miss anything, but that should be hopefully good. Or at least maybe most of the idea, which apparently it is not. But that's okay. I got one problem, right? One contest. I mean, one test case, right? I just returned 0 and everywhere. Maybe I don't set it. That's wild. Right. Well, what is? I mean, the good thing is that the examples do have visualization, which is good, and this one is very clear. For this one, that it should be 2. So that is interesting. So we can do maybe print xy stack. I mean, I know that it's probably going to be empty. That's why everything is 0. But I just want to confirm. Oh, I'm dumb. I just never updated p. I meant to, but then I didn't. Should I? Yeah, I mean, I was going to. I think I confused myself a little bit because I thought when I wrote this, I thought I would just do it incrementally, which is fine. And then by the time I got here, I just forgot. And what I mean by that is that I thought I would pre-process it, and I just didn't, right? Because it cannot contain. I mean, I think the tricky part about pre-processing is that sometimes you have to take care of itself. Like you have to handle itself, and sometimes that's a little bit tricky. But I don't know. It's fine. We just have to write this. Hopefully, we just only have to write this. Sweep length of p list and int. This is a list, I suppose. Yeah. P of x of this. Previous x. No, previous. Oh yeah. All right. Still wrong. But now we're returning 2 for everything, which is also awkward for this. But, well, you know. XY and stack, right? I mean, if it's returning 2, you could kind of guess what it is. But, that is not what I thought. Where does the 2 come from? No, that's not right. Wait, where does this y come from? I mean, this y is the current xy. Why do I append this? I mean, yeah, this is probably why, but why we're having issues. Next y, right? This is very weird. I think I confused some concepts and my coding is weird, right? Okay, so sweep, right? So that means that this is not y. This should not be y. This is like this y. Which is a little bit awkward, honestly. And we have to check that. Oh yeah, I don't know. Maybe I'm just confused on this part because yeah, if in the sense that I don't know. Sometimes I mean when I'm coding, like I am okay, but sometimes I talk too much and I just confuse myself. Talk my way out of it. All right, so this looks good. Is it expected? Yes. And this is also Gucci. Yeah. That's good. And then now the answer is 1, but it should be 2. And 1. Oh, okay. I mean, this is just actually I I mean, I talked about this with the greater than equal to, and then I just gotta mess that up, I suppose. Yeah. It's either there's an off by one somewhere. I don't think it's this one though. Is it this one? We go to the next one if no. I mean, so then P sub thing should be good, right? 1 1 is Gucci, and then it goes to 1 3. Doesn't do any. Oh, I forgot. Okay, actually, no. This isn't. This is something that I was saying earlier, but then I just forgot. I just totally forgot, which is the easy fix. We actually kind of drew this earlier, right? This is the thing on the left side. I'm trying to switch windows, hang on. This is the thing on the left side where if everything's on the same X, then you just plus 1 on the previous one, right? Symbol fix. Yeah. And this is you can write it any other way. So if I is greater than 0, just increment 1 or something, right? Huh. Oh, it's not this I. I'm dumb. It should be. I forget. I'm just because this I is not the I that was in my head. Like I said, I lose track of stuff. I'm getting old. I'm sorry. But it should be the first number, right? So if it is not the previous X, that means with a new thing. But if it is the same as the previous X, then we can just increment by 1 because that means that there's something on the same X, and then we should be good. Okay, that's YOLO submit. Maybe I missed a silly case, which is fine because I am lazy and I just want to go to bed, and it's been half an hour. Did I time out? If I time out, that would be kind of sad, honestly. But yeah, I mean, that seems okay, right? And we didn't even, I said that I had an n square log n thing, but then we got rid of the log n because we end up using this sweep line. So it's going to be n square in case you're curious about complexity. Yeah, because, I mean, the sweep is O of n per element. Hope you make sense, right? Because at first you just look at every element once, and that's just like very lazy. You could amortize it a little bit more if you really want to be precise. And then the stack, well, the stack there can only be n previous numbers on the stack. So yeah, so that's also probably good. I'm curious whether no, I mean I think maybe you could clean up. I don't know if you could reuse stack to kind of like save time or something, but maybe you can. I don't know. I'm not going to think about it though. Apparently my code is very slow, but apparently also in line with what I did last time. What did I do last time? Oh, yeah. That's about the same speed. I mean, we actually talked about this solution, and this is going to be the n square log n solution, where the binary search, I guess it's just, I'm actually surprised that the running time is about the same though. But I mean, we were debating doing this. I was like, you know, I mean, you were here. If you're watching, you probably agree. That said, this looks a lot faster to get it done. Where from this one, maybe a lot more complicated, right? But this is n square log n, and this is n square, right? Plus n log n, if you will, somewhere. But obviously dominated by n square. And that's it. That's all we have for this one. Let me know what you think. Thanks for watching, and you could do it the other way if you watched that video though. That do I write it 2 different ways? No, I just both did it with binary. Alright, well, it is what it is. I don't know how I feel about that, but I am feeling sleepy. That's how I know. That's what I know. So thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.